Good morning, students. Nice to see you again from school physics lab. The topic that we are going to see today is loudness of sound. Loudness of sound. In the previous class, we saw the characteristic of sound called pitch. Okay, we studied about pitch. We saw what is low pitch, what is high pitch, and how can sounds of different pitch be produced and all that. Okay, today we are going to see another characteristic of sound. Whenever a sound is produced, we can talk about its loudness. Simple example. In your when you're hearing through your mobile, if you keep your volume low, you hear a very mild sound. If you keep your volume high, then it is going to be a louder sound. Okay, so loudness, there are two possibilities. You can either produce a loud sound or you can produce a soft sound. Okay, soft, or sometimes it is named as feeble sound. Okay, you can either produce, loudness can be either loud sound or soft sound or a feeble sound. Okay, so that is what is given in the book in the first paragraph. In the definition, the loudness of a sound is its characteristics due to which we are able to distinguish between a loud sound and a weak sound. Even soft sound, feeble sound, even you can call it as weak sound. That is the definition of loudness. Okay, so next we'll quickly go to the factors affecting loudness. Factors affecting loudness. So loudness depends on at least three factors. Okay, loudness depends on three factors. First is amplitude of vibration. This is the main thing. Amplitude of vibration. Simple example, a drum. Okay, you hit it with less energy. You hit it mildly, you're going to hear a soft sound. You hit it very fast or with all your energy, then you're going to hear a loud sound. What is the main difference between both the waves? It's the amplitude that is going to be different. Now, if I have to draw a diagram showing a loud sound and a soft sound, a loud sound will be like this. The amplitude will be quite high this time. So can you see, this is the amplitude. Amplitude is high for a loud sound. But for a soft sound, the amplitude will be less. Okay. So for a soft sound, the amplitude will be less whereas for a loud sound, the amplitude will be large. So this is the main factor that affects the loudness, that is amplitude of vibration. Okay. Now the second factor, loudness depends on the distance between the source of sound and the listener. Source of sound and the listener. Simple example, in a table, in a classroom, children sitting in the first row might be hearing my voice loudly, but children at the last row, they may say, "Ma'am, we are not able to hear you." Why? They are sitting at a longer distance. Okay, so as you sit closer to the source of sound, then the loudness will be more. As you go far away from the source of sound, the loudness here will be less. That is the second factor. Okay, distance from the source of sound. Distance between source of sound and the listener. Then the third important factor is surface area of vibration. Surface area of vibrating body. Surface area of vibrating body. Okay, so the more the surface area, the more will be the loudness. Okay, now before going into it, I have to turn to page 118. Page 118. There is something called tuning fork. Okay, you have to understand this first. Okay, so a tuning fork is you can't say musical instrument. We use this in the lab, okay, to produce sound of a particular frequency. Its unique feature is it can produce sound of only one frequency. On a guitar, the other day I showed you how you can produce sounds of different frequency, or in a flute. Whereas with this tuning fork, you can only produce a sound of single frequency. So it is written 480 Hertz. That means this can produce a sound of frequency 480 Hertz. That's all. That's why it is called monotone. Okay. It is called monotone, means it can produce only a sound of single frequency. Okay, mono means single, tone. Okay, so it can produce a sound of single frequency. So monotone example will be tuning fork. Okay, it's a tuning fork. Okay, it looks like a fork like this. So it's called a tuning fork. Okay, so now I'm going to hit this with this hammer. It's supposed to be a hammer. Then you will hear a sound, okay, sound of single frequency. Okay, you can watch this carefully. Okay, hope you could hear that. Okay, so with the tuning fork, okay, if you hit it with this vibrates and then you hear a loud sound. Now quickly the parts of this. Okay, usually you should use a rubber hammer. In your book, in this picture here, they have shown a rubber hammer, but I am not using a rubber hammer. Okay, then these are called the prongs. These two are called the prongs, and this is called the stem. Okay, so a tuning fork looks a very simple diagram, U kind of a thing. These two are called prongs, P-R-O-N-G-S, and this is called the stem. This is called the stem. Okay, so now with this, now I'm going to, let's go back to this third factor, surface area of vibrating body. If I just hit it and you hear the sound, you hear a milder sound. But the same thing, if I hit it and keep it on this table, okay, there is a table whose surface area is very large. So if I keep it there, then you will hear a much louder sound. So are you able to see the difference, children? When I hit it with my hand, just holding this, I didn't hear such a loud sound. But when I hit it and kept it on this table, because the surface area of the table is very large, okay, you heard a louder sound. So that is what the third factor says. Surface area of vibrating body. The other example is, if you see a drum, okay, we have a school band, they have this big bass drum, the big drum, so that is quite bigger, the surface area is very big. That's why when they hit it, you hear a louder sound. Whereas, if it is a small drum, you hear only a lesser sound, okay. So, more the surface area of vibrating body, more will be the loudness. So, that is the third factor that affects the loudness, okay. Next, unit of loudness. Unit of loudness. Loudness is generally measured using a unit called decibel. Decibel. Basically, it is bell or decibel. Okay, like meter or centimeter we have, something like that, bell or decibel. Okay, now this name came from Remember Alexander Graham Bell, who invented telephone? Okay, so sound or something related to that he invented. So this unit of loudness, they gave this name after his name, from his name. So it is bell. Decibel is a smaller unit of bell. 1 decibel will be 1/10th of a bell. Like how you have 1 decimeter is 1/10 of a centimeter, something like that. 1 bell is 1/10 of a, 1 decibel is 1/10 of a bell. So this is the unit. Okay. Now, so we have some examples from our daily life. Examples from our daily life. Okay. The normal sound, maybe the loudness with which I am speaking to you now. Okay. The normal loudness. This might be from 40 to 50 decibels. Okay. Normal sound is generally, the range of normal sound is 40 to 50 decibel. Okay. But a sound which is loud, okay, a loud sound can be between 60 to 80 decibel. Okay, a loud sound can be, its loudness can be from 60 to 80 decibel. And then noise, the loudness, when it becomes too much, it becomes noise. It's not very pleasant to hear and we don't want to hear it for a longer time, and we call it noise pollution. Okay, so when the sound loudness becomes greater than 80 dB, you understand this greater than symbol? Yeah, when loudness becomes greater than 80 dB, then it becomes noise. It's not a pleasant sound. We don't want to hear it for a very longer time and we just want to get rid of that. Okay, that's called noise pollution. We can say call it as noise pollution. Generally, the loudness of those sounds are greater than 80 dB. One more thing you should know, if you hear a sound greater than 120 dB, now this, if you see in your table, this will be jet plane, okay, rocket at takeoff. Now these things are very high sound and the loudness will be very high and a constant exposure. So once in a while it's okay. But if you, now suppose some companies, they have machines which make loud noise, okay. Till this it's okay, but if it's above 120 dB and if a person is exposed to it for a longer time, it can even cause permanent ear damage. The person can lose his hearing. Okay, so it's very important that the sound we hear, okay, should not cross 80 dB. They say the safe limit is till 80 dB. Beyond that, it's not good. Okay, so beyond that it's not good, and sound above 120 dB is really very dangerous for us. Okay, okay. There's another heading, loudness also depends on sensitivity of the listener. Sensitivity of the listener. This means how good you can listen or how sensitive your ears are. Okay. Sometimes you'd have heard this. Old people, sometimes they cannot hear properly. They lose their hearing naturally with age. Okay. Their sensitivity of their ears are not very good. Okay. So, they may not hear sound very loudly as you hear. Okay. Your ears sensitivity is very high. When we are young, the sensitivity of our ear is very high. Then the sound that we hear is also loud enough. Whereas, as you get older, sensitivity might decrease and you may not, the sound may not look so loud. Maybe you go and shout in front of a person who is deaf or who is not able to hear properly. Nothing will make any sense because they have lost their hearing. Okay. So, that is also another factor that affects the loudness of sound. Okay. So the last part in the book, they have given a musical instrument called Jal Tarang. I don't know whether you've heard about it. Okay, this man, he has kept bowls, okay, of water, and the water levels should be different in each bowl. Water level should be different, and you should use a glass or a china clay. Okay, don't use a plastic or a steel. A glass or a china clay bowl if you use, and you heat it with this, then you will be hearing a sound of different frequency. Each one will produce sound of different frequency because of the difference in level of water in each of this. Okay, if you want, you can try this. This produces a sound and it is called as Jal Tarang. Okay, Jal Tarang. We can see it in, you would have seen it in some TV programs or something. That is by changing the amount of water in each bowl, you can produce sounds of different frequency. They can even produce music out of it. Okay. Yeah. Now you can open your book, children. Let's mark from the book. Okay. Turn to page 119. Okay. Page 119. First is the definition of loudness. It starts from here. So I want you to mark properly, and in the question answer, if I ask define loudness, I want you to write only this one, not anything else. Okay. The loudness of a sound is its characteristic, due to which we are able to distinguish between a loud sound and a weak sound. This is the definition of loudness. Next, come to factor affecting loudness. So 3 factors. Loudness mainly depend on amplitude of vibration. Greater the amplitude, louder is the sound produced. Mark till this. Okay, if they ask you factor affecting, you have to write till this. Okay, then they have given example. When you whisper, you use very less energy. So amplitude of vibration is less, and so the sound is weak. But when you shout, you use more energy. Amplitude of vibration is more, and hence you hear a louder sound. Second factor, loudness depends on the distance between the source of sound and the listener. Distance between source of sound and the listener. Okay. Now here, this explanation, you please strike it off. This is not needed. Okay. In place of that, please write what I have written here. If the listener is close to the source of sound, the person hears it quite louder. But if he is far away, the sound becomes feeble or weak. Okay, you can say feeble or weak. You can pause the video and note it down. So under this point, this is what you should write. Third one, loudness depends on the surface area of vibrating body. In this you should write, larger the surface area of vibrating object, louder is the sound. Okay. The next one is loudness and waveform. So I'll tell you, draw the graph of 2 sounds, one soft sound and one a loud sound. So soft sound means the amplitude should be small. In loud sound, the amplitude should be large. Okay, you should draw these 2 waves. Then there is another factor that affects the loudness, that is sensitivity of the listener's ear. Sensitivity of listener's ear. Okay, sensitivity of a listener's ear decreases with advancing age. It is due to this reason that older persons are hard of hearing. Okay. Then unit of loudness, bell or decibel. 1 decibel is 1/10 bell. It was named after Alexander Graham Bell. Now you can cut this off. This also is not needed. Come straight here and give an example here. Examples from daily life. Examples from daily life. Okay. So in this I want you to mark 3 things. Ordinary conversation with your friends, loudness level will be 40 to 60 dB. Ordinary conversation will be 40 to 60 dB. Okay. If they ask you what is the level of loudness for ordinary conversation, 40 to 60 dB. Then second point I want you to mark is sounds above 80 dB cause noise pollution. What is noise pollution? unwanted sound that we hear and we can't hear it for a very long time and should be avoided. Okay, the DJ and all that what you hear during a party or wedding ceremony, loud DJs, so they are comes under, their sound will be above 80 dB and that can cause noise pollution. Third, I want you to note down this information that I have given. A constant hearing of sound level above 120 dB. If a person constantly hears a sound of above 120 dB or greater than 120 dB, can cause permanent ear damage. Okay, can cause a permanent ear damage. Okay, so this also gives you, you need not memorize it, but it will give you a rough idea about, see, rustling of tree leaves means the slow movement of tree leaves. It may be 10 dB and that is very, very faint sound. Okay, so like this keep going on. Ordinary conversation 40 to 60. Factory noise 100 to 110. Okay, so above 120 if you see, there are two examples. Jet plane, rocket at takeoff. So these are painfully loud, means these can cause permanent ear damage. Whereas these ones are very loud sound. So give some example of very loud sound. You can write, okay, this is very loud. Okay, heavy traffic in metropolitan city, factory noise, rock concert. Okay, so these are examples of loud sound. These four are the examples of loud sound. Okay, so with this the chapter is over. Okay, so it was a comparatively small chapter and I'll be giving some question answers. You can write the answers for this for that and send it back to me. Okay, please, while writing the answers, don't check in the internet. The other day the answer gives some examples of low pitch sound, high pitch sound. I think some of you had typed the internet and you got some funny answers. I typed and I got the same answer what you got also, and I know who, I think who did that. You are able to remember. Okay, I have even sent a message to you. Please don't do that. The answer should be based on the information given in your book, not just from anywhere. Okay, because it may be right or may not be right. Please don't go by that. Please hear the video and the answer should be according to what I am explaining here. Don't just see the internet and write the answers that comes there. That might be wrong. Hope you have understood, children. So do your homework and send it to me. Thank you so much.